In this video, we're going to learn about solving linear inequalities. The best way to start this is to start out with a nice example with the vague directions solve, which means we're working with an inequality in this case. Our first one that we are going to tackle is x is greater than 2. Now, some of you might be going, we're done here. There's our solution. No, because let's just think of some solutions that could satisfy this statement. In fact, let's write that down. This is a statement, okay? Inequality is a statement. It is not a solution. In order to solve, we need to write it in a very special way, okay? So you could dream up a few. You could think of 3, right? 3 is greater than 2. You could think of 2.000001, which is greater than 2. It's just a little bit bigger. And we would be here all week coming up with different values of x that could satisfy this statement. Now, there are 3 ways that we can write a solution to this statement. The first is the most intuitive because it is visual. We are going to graph it. So we are going to start with a number line. And you can fill out your number line as detailed as you want, but the most important thing is to write down the number that x is being compared to. In this case, x is larger than 2. So I'm just going to plop a 2 down. If you want to, you could fill in the 1s and the 0s and maybe a 3 or something. If you go any further than that, it's excessive, but you can if you want to. The main point is that 2 is our point of interest. Now, when we look at it, because that's our point of interest, can x equal 2? Is 2 greater than 2? And hopefully you're shouting no at me for your computer screen. It is not greater than, it's actually equal to. So when I graph this solution, I don't want to include this value. So I'm going to write an open circle. That says we get really, really close to 2, but 2 is not a solution. Now, x is everything larger than 2. When we go larger, we're headed off towards infinity, getting bigger. So I am going to shade in on my number line, and I'm just exaggerating it. You can just draw one solid straight line all the way off to infinity. And there's our solution. We're done. Now, the next way that we can write our solution comes after graphing. Usually interval notation is easier once you've already graphed it in your head or on paper. And interval notation basically reads the graph. So we need to start at 2. We do not wish to include 2 as a solution, so we use a parenthesis to note that. And then we continue on all the way to infinity and beyond. Okay? These 2 solutions are beautiful. They're each a type of solution. Now, the last one is probably the most obscure for most students, especially those not headed into math or STEM fields, and that is set notation. Set notation is a unique way to write. We have the set, and you should remember this from solving linear equations where we use curly brackets to note our solution values. Now we have the set of all x is our variable, such that the statement x is greater than 2 is satisfied. And that's it. And you feel a little empty inside because you're like, wait a minute, you didn't write anything else different than what we started with. Yeah, but this is saying set notation. It's saying all of those values of x that satisfy this, not just one of them. If you leave the vague statement x is greater than 2, you could just find one value of x that makes it true, and then we'd be done, which is actually false because there are infinite many solutions there. But those infinite many solutions depend on x being larger than 2. So these are the 3 ways that we write our solutions. Let's go ahead and see a couple other types where maybe we don't have the strict inequality. Okay, this is where x is just larger than 2. So let's see where x is less than or equal to 2. So we're going to graph it. And when we graph this, we're going to go straight to our number line. In this situation, I'm just going to bring up 2 because it's the only point of interest. And we have a little new curveball here. We have less than or equal to. So we want to include 2 as a solution because 2 equals 2. In order to include it, we are going to use the symbol, not the open circle because it says don't include it. We want a circle where we shade it in. So a closed circle is what we use. Now, the inequality is facing towards the 2. So x is less than. X is smaller than 2. We are going to go all the way to the negative infinities. We are going to go on the left of this graph. So we have graphed our solution on the number line. We can write this in interval notation, and I'm going to abbreviate interval notation as IN. We have negative infinity until we hit 2. And now I'm going to take a pause here. We have 2 is a closed circle, so I want to include that. Parentheses do not include the values. We are going to use a square bracket. Now that tells the reader it's or equal to. Now you might be thinking, whoa, 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 you use parentheses on this infinity symbol. Isn't it including that? No, I don't know what negative infinity is. Negative infinity keeps on getting smaller and smaller and smaller and smaller. It's an infinitely small number here. So that's why I use the parenthesis because I can't ever stop. There's no stopping point, so I don't include it. So you can write a note to yourself, you never include infinities. And let's just sneak back here to our other statement. Here we had positive infinity, and we used the parenthesis there. You always use parentheses for infinity symbols, okay? The only thing that is changing is the numbers, the constants. 2 here is not included because there's no equal, but 2 here is included because of the or equal to. And last but not least, our set notation is the set of all x such that x is less than or equal to 2. Fairly nice. Now, these are 2 very nice statements. They were already simplified for us. We're just learning it. We'll have harder examples in another video. Let's just see one more type of solution with these inequalities. And it's one of my more favorite ones that we see. It's a compound inequality. So we have 0 is less than x, which is less than or equal to 2. Graph. Always graph. Mentally graph or write it on paper is the safest bet to do when you're working with inequalities and solving them. In this case, we have 2 players of interest here, 0 and positive 2. And x is trapped between these values. X is larger than 0, right? We can read this 2 ways. 0 is less than x, or we could say x is greater than 0. 0 is not being included, so we have an open circle because of that inequality. It's a strict inequality. X is less than or equal to 2. Now that or equal to means we are including that value, so we use the solid circle on the 2. And x is somewhere in between these 2 values, so there are infinite possibilities between these 2 little finite interval. And there we are. So when we write it in interval notation, we are just going to say 0 parenthesis, right? Because we're not including that value because it's a strict inequality. Because of the or equal to, we are going to have a square bracket. And of course, our favorite set notation, you're probably going, how gross can this get? Not that bad, actually. We have the set, the variable is x, such that our statement is true. And those are the 3 ways we can write our solution. Now, that is all necessary. There is one thing we really need to know before we get into harder problems and actually do a little bit more work. And that is the rule about solving inequalities. So, pretty much what we are going to do is tackle a new problem. Let's put it off to the side, treat it as kind of a gross one. And let's say we have where we are asked to solve the inequality negative x is greater than or equal to 2. Okay? Let's say we have to do this. Pretty much our inequalities follow the exact same rules as solving linear equations. And let's remind ourselves of those steps. First step, we simplify as much as possible. Okay? Combine like terms, get rid of parentheses, clear fractions, any of that good stuff. Make sure we have one variable on one side of the equation. In this case, we only have one. Woohoo. Next, we are going to do addition property, and last, the multiplication property. Okay? So we follow those steps just like we did with linear equations, except now if we multiply or divide by a negative, there is an exception. Okay? And we are going to write that in rules. If you, the manipulator of the equation, if you multiply or divide by a negative, by a negative, then we must flip. And flip is not the proper math term. It's just kind of a nice way to remember it. Flip the inequality. So that is our new special rule that we have, but everything else is the same. Whatever we do to one side, we must do the same to the other. So we have a negative here. Don't like it. Got to get rid of it. So we're going to manipulate this inequality where we divide by a negative or multiply by a negative. It actually really doesn't matter which route you go here because one is its own reciprocal. And we are going to go ahead and just divide because I think most students think that way. And we are left with negative divided by negative is a positive. This inequality flips according to this rule, and we have negative 2. And now you can write this solution any way you want. I'm going to use set notation because it is quick to me, and you can graph it, and there's your answer. Let's real quickly, before we end, talk about why this is true, okay? Now, I think understanding why this rule has come about makes it easier for students to remember. And let's just start off with a statement that we can all agree is true. 0 is less than 10. I think you agree with me. 0 is definitely smaller than 10. Now, if we mess with this inequality, let's say I add 1. And what I do to one side of the inequality, I do to the other side. 1 is still less than 11, so it's still a true statement. Let's say instead of adding 1 to this, I'm just going to divide this into 4 sections here. Let's say I subtracted. Let's say I subtract 1. What I do to one side, I do to the other. Well, 0 minus 1 is negative 1. 10 minus 1 is 9. 9 is still larger than negative 1, so this is still a true statement. So we've messed with this by adding and subtracting, and it didn't cause us to flip our inequality. Now let's mess with multiplication, okay? Let's say I multiply by positive 2. So I'm going to times, and I'm just going to use a different color here, this by 2 and this guy by 2. What I do to one side, I got to do the other. 2 times 0 is still 0. 2 times 10 is 20, and 20 is larger than 0. The inequality is still facing the same direction. But now let's say we multiply by a negative 2. 0 times negative 2 is still 0. Negative 2 times 10 is negative 20. And now that inequality would not be true if it faced the same direction. Negative 20 is a smaller number than 0. So the inequality flipped. And that is how I usually tell my students, if you cannot remember the situation that the rule is different, come up with some trial and errors. Add, subtract, see that it doesn't flip the inequality. Multiplying by a positive doesn't change the inequality. But sure enough, when you do that negative, you have to flip that inequality. That's all.